Hello, everyone. Welcome to today's stream. Really excited about this stream. We're going to be talking about Bentley's LumenRT and we have and Cesium, and we have folks from Bentley and Cesium here. And of course, we're joined by Krista and Robert from the AECO team. Thank you so much for joining us today. Before we dive in, Edmar, do you have any announcements or anything we want the community to know about?
I think the main one is that we've got that community challenge coming up next week. I just talked about. We're going to be posting announcements about it on our Discord server. We actually have a channel called Community Challenges. So if you're not on our Discord, that's the best place to come hang out and talk to other users. You can talk about this live stream afterwards. If we have a few minutes after this live stream ends, maybe we can get everyone here to come on our Discord server for a few minutes and take some questions live. Discord.gg/NVIDIA Omniverse. And then next week, on our live stream at the same time, we're going to be chatting with the good folks from Adobe. We're going to dive into some Substance 3D workflow with Omniverse. And then the other big thing is Jensen, I just mentioned a few minutes ago, is going to be speaking at Computex, May 28th, which is a Sunday, so you have no reason to miss it. It's going to be a great one. The team here is all working on all the nice show and tell. It's going to be part of that keynote, so it should be pretty exciting. But very excited for today. I have to say, AECO team puts together the best content of all the teams we work with. Don't tell the Isaac team I'm saying this, but you guys put together amazing live stream content, and I'm blown away that you guys got these great guests today. So Krista, what's the plan for today, and who are these beautiful people?
Yeah, welcome to our fourth AECO live stream. Today we're super excited because we're actually getting to bring in some of our partners. So I just wanted to thank Dave from Bentley Systems and the Cesium team for joining us today. It's super exciting. I know a lot of people in the community are super excited to hear from you guys directly. And I will go ahead and let you guys introduce yourselves and tell us a little bit more about your platforms. So Dave, why don't you kick us off?
Sure. Dave Burdick here. I'm the product director for our digital delivery solutions and visualization. Happy to be with you. You can see I'm from Reno, Nevada, over here with the mountains behind me. And today we're going to walk you through some of our new capabilities that we just announced and introduced at the GTC last month, our LumenRT for Omniverse solution. So very happy to be with you today.
Thanks. And Ryan, why don't you go ahead?
Yeah, cool. So my name's Ryan. I'm a solutions architect here at Cesium. As you can probably tell, I'm not in the States. It's nice and early in Australia here. Cesium, for those who don't know, is a open platform for 3D geospatial. We've got a variety of different open source technologies for effectively feeding or streaming 3D geospatial data into web applications, game engines such as Unity and Unreal, and obviously today we'll be covering our Omniverse extension. I've been working in the AECO space for about 15 years, particularly on major transport and built environment projects using real-time 3D graphics. So anything from the early days of using open source engines like Ogre 3D through Unity, Unreal, and all of those sort of technologies in between. So really excited to be here doing this in the Omniverse space.
Awesome. Thank you, Ryan. Then Adam.
Yeah, I'm Adam Morris. I am one of the 3D graphics engineers at Cesium. And for the past, half a year of my life, I've been working heavily on Cesium for Omniverse, and we're really happy to actually have that shipped to users. And we encourage everyone to check it out if they can.
Yeah, we've been using it a lot on our team. It's awesome. And last but not least, Sean, go ahead.
Yeah, hey everyone, my name is Sean Lilly. I'm also a 3D graphics developer, primarily working on Cesium for Omniverse and having a great time with it.
Thank you. All right, so yeah, today we're going to have Dave talk to us a little bit about LumenRT for NVIDIA Omniverse, and then we'll have the Cesium team talk a little bit about their extension and then actually do a live demo for us, which is super exciting. So Dave, you can go ahead.
Great. Okay, so in the interest of bandwidth, I'm going to shut off my camera and then share my screen. Is it okay? I hope so.
Sure.
Go for it.
Okay.
We'll miss the mountains, but...
Okay, you're going to miss the mountains. All right. Let me share my screen here. 1080, go live. Okay, and then bring up my presentation here. So everyone can see my screen okay?
Yep, looks good.
Perfect. Okay. So I'm going to walk you through LumenRT for Omniverse. I'm going to carve it up into three pieces. We're going to first talk about the key challenges for creating high fidelity project visualizations. In the infrastructure space, we have significant challenges that may differ from other industries, so I want to share those with you. The second piece is we're going to talk about the importance of digital twins and how our customers are now reaping tremendous benefits from using and adopting digital twins and how it fits into the visualization workflow. And then finally, I'm going to walk you through some of the new features and capabilities of our LumenRT for Omniverse project, and then we'll talk a little bit about how we're using Cesium as part of that, and then I'll hand it over to the Cesium folks. So let's continue. So as I mentioned, the infrastructure projects are a little bit different than other kinds of projects in that these projects are generally extremely large and they're complex, and they generally span city-scale geographies and encompass facilities and assets containing millions of components, tons of raw materials, and thousands of stakeholders. So these they present unique challenges to us to handle the scale of these kinds of projects, as well as the ability to do this with millimeter grade accuracy. So the infrastructure projects are also quite diverse. They span many different application domains, such as civil, water, energy, utilities, and subservices. The good news is that our friends at NVIDIA with Omniverse are making handling these massive scale visualizations possible with their continuous introduction of faster and ever powerful, more graphics hardware, and of course with LumenRT for the Omniverse platform. So the takeaway here is now we believe we can, for the first time, conquer just about any size infrastructure visualization project, provided you're taking advantage of the new graphics hardware and capabilities from NVIDIA. So my advice is to make sure that you're modernizing your visualization architecture, not only with the latest software, but with the appropriate GPU hardware. The second key imperative with respect to infrastructure visualization involves scope. And here, traditionally, high fidelity visualization has been sort of the exclusive province of early stage pursuit presentations and things like bid proposals, for creating the Hollywood style visualizations to win the deal. Going forward, however, we see a number of really new exciting areas of opportunity across the broader infrastructure project lifecycle that are much more utilitarian. So things like high fidelity multi-user immersive design reviews, incorporating real-time physics and simulation for analysis and design validation, providing richer animation capabilities for construction schedule animations and site rehearsals, and then also leveraging digital twin operations and maintenance for immersive training and AI-based inspection. So the bottom line here is that we believe that high fidelity visualization is going to move beyond the area of just simply creating sort of Hollywood style productions and move and provide much more significant value across a much broader set of use cases. Okay, so the next area imperative is what we call the synchronization, and I think this is really one of the greatest benefits of adopting digital twins, and that is keeping visualization synced with the project. This has always been one of the most difficult problems to solve. Infrastructure projects can, for example, experience hundreds of design changes throughout the day and during the design and construction, and trying to keep all of those changes current with the visualization is next to impossible unless you adopt this new way of working with digital twins. So if your company is still relying on the older CAD and file-centric approaches for creating visualizations, you have no hope of ever keeping that visualization current. So what we recommend as part of this move towards Omniverse is to use it in conjunction with digital twins and adopting this new industrial strength syncing mechanism so that you can make sure that your engineering information is synchronized with the actual visualization you're producing. Okay. The final imperative here is on simulation. So there are two aspects of this. The first is geospatial simulation, which we're going to hear more about when we turn it over to the Cesium folks. So what geospatial simulation does is provide a rich context for how the project actually connects with the surrounding environment. So here, geospatial tools like Cesium that provides allows you to take geospatial information and reality meshes and integrate that directly into digital twin. So you get a complete understanding of the full aesthetic and the environmental issues within the project. So infrastructure visualizations without this, geospatial context are essentially naked, and they lose much of their usefulness. The second piece is the actual behaviors within the infrastructure project itself. So this is about connecting ground truth data and animation directly into the visualization. So here, what we're trying to do is to provide solutions for all of our modeling and simulation tools. This is our traffic dynamics tool. We have tools for simulating pedestrian movements through transit corridors. We have simulations for construction sequences, etc. All of these ground truth simulation capabilities we're now integrating into Omniverse through our LumenRT product, which deliver heightened levels of realism, analytics, and insights for infrastructure projects. Okay, so let's talk a little bit about now the infrastructure digital twin. So everyone has a different definition, for a digital twin. Our definition is that we define a digital twin as a synchronized virtual representation of a real-world asset. It's basically a digital version of reality that is continuously updated, and that's the critical point, that this thing is not static. It's constantly changing and constantly evolving and constantly being updated. So the infrastructure digital twin encompasses the goal of being able to work much more effectively and to achieve better project outcomes by leveraging information across the entire design, build, and operate project lifecycle. And there are two fundamental aspects of this. The first is we're designing and delivering our projects using a rich 3D context. And this is really where, again, the geospatial capabilities of Cesium come into play. So we're not just working in a very naked, empty CAD model. We understand how that CAD model and how that information connects into the actual real world. The second part of that is what we call information agility. This is about leveraging the information in the digital twin to allow you to go faster and deliver projects with higher quality and less cost. So to do this, you need to have the right information connected to the right people and deliver in the right format to make better decisions. So the net of this is the digital twin makes it much easier to solve small problems and do this quickly before they become big, expensive problems. So there are several real great benefits for using digital twins and adopting these for visualization workflows. So the first part of this is that when you use a digital twin, it makes it much easier to normalize and pull all the data together. The bane of most people that are creating visualizations is that, when they're given a job of creating a visualization, they go on this giant paper chase to gather and composite all the necessary models together in order to create the visualization. The digital twin just handles this as a fundamental byproduct of creating the digital twin. It's also much easier to do storytelling with digital twins because of its native ability to partition models into logical chunks. So for example, I can break the model up into zones or specific categories or project milestones in order to create much more concise visualizations. And as I mentioned before, perhaps the greatest benefit in using digital twins is that it provides a vehicle for the first time to sync the project model with the visualization model. So this ability keeps the models in sync via simple fast change set updates. And this is really a breakthrough feature. It's going to save time and money and aid in dramatically improving the quality and the trust that the visualization you're looking at is actually synced to the actual data. And then finally, using a digital twin schema, we can easily create automated material mappings that transform dull engineering models into vivid, lifelike scenes using high-fidelity materials from Omniverse that I'm going to show you later. So the net of this is I hope I've convinced you that if you really want to get to the next level of visualization and visual storytelling, the way to do it is not, the old method of, taking a bunch of CAD files and then making it look better. The right way to do it is to create digital twins and then synchronize your visualization to that digital twin. Okay. Now for the fun stuff. Let's talk a little bit about our new product. This is Bentley LumenRT for NVIDIA Omniverse. So I'm pleased to say that we've introduced this product. It went live last month. Many thanks to all the hard work and effort, both on the part of Bentley and NVIDIA, the NVIDIA team, to make all this happen. So we spent this collaboration, and is a result of a several-year collaboration between Bentley and NVIDIA to bring the combination of infrastructure-grade digital twins using our iTwin solution and coupling that with NVIDIA's outstanding Omniverse visualization platform. And together we're blazing new trails for delivering high-fidelity visualization to the most innovative and demanding infrastructure projects across the world. So what I'd like to do now is to walk you through some of those key features and capabilities. So the first capability is the actual launcher itself. Oh, well, excuse me. Let me back up here. So to access LumenRT for Omniverse, we're doing this a little differently. We're actually now fully integrated into the NVIDIA Omniverse launcher. So to do this, all you need to do is to download and install Omniverse. Hopefully everybody that's watching this call has done that, or hopefully will do that after this call. And once you've installed the launcher, we have an application there. You go to the application section, and then you can launch Bentley LumenRT for NVIDIA Omniverse. So once you launched it, very simple, it's fully integrated, as well as the documentation. The release notes and updates are also accessed via the launcher. And then after you launch it, you get a 30-day free trial. Okay, so let's talk about some of the capabilities here. First is our connection into the iTwin here. What I'm going to show you. So right now, let me actually pause this for a moment, and then. So what you're seeing right now on the screen, this is our Synchro control product. It's one of our iTwin solutions, and we're looking at this on the inside of the Synchro control visualization web-based browser. And what we're going to do now is we're going to transfer this directly into Omniverse. So we go into Omniverse, we fire up LumenRT, we go into our project and navigate it, and boom, we bring the model directly in. So once it's in here, of course, we can create all these beautiful visualizations. We can either load twins, online, or we can work offline. So if you're in an area, that doesn't have, a high-speed internet connection, you can just download those models and work with them offline. We also allow you to work with either the full iTwin or use save view subsets. This was going back to what I talked about before about partitioning. So the next really, really cool feature is this ability, as I said before, to sync the changes in the actual iTwin with inside of Omniverse. So I'm going to run this here now. So what you're seeing, this is a train station. What we're going to do is add the roof structure. So this is in the inside of iTwin. So I go here into the iTwin. I simply say update this. I point to the latest change, and I click on it, and boom, here comes the change. And now you can see the updated iTwin model. So this is really a breakthrough. The update is extremely fast and leverages all the changes that you're doing with your engineering teams or your project teams on iTwin get automatically reflected in real time, with using the Omniverse Connector. Okay, so let's talk a little bit about the next key feature. This is our material mapper. So what we've done here is we've created an integration between iTwin materials and NVIDIA Omniverse materials. The way it works is you read the schema of the iTwin material mapper, and then it will take this schema. As you can see here, it's basically a CSV spreadsheet, and you can define what high fidelity Omniverse or MDL materials you want against the original iTwin material. So it creates this template for you what's great about this is you can save these templates and then import them and apply them on all future iModels that you bring into Omniverse. So you do this once, you create and name the mappings that you want, and once you've done this, you can reuse this on all of your iTwin integration. So it makes it really, really simple to avoid the laborious process of going through the models and individually adding materials, object by object. Once you've created this template, you use it at the time of import, and it automatically injects those materials in the model. Okay. So one of the things that we've done, if you're familiar with our LumenRT Connect product, is that we ported over our video clip timeline editor. And what this does is provides a very, very simple mechanism for creating visualizations and fast, easy camera path creation. So the way it works is that you simply move your camera, you click that I want to create a keyframe, it generates a keyframe, and then it automatically creates the interpolation between the keyframes to create smooth paths. And of course, you can set keyframe transition and hold times, and then generate really cool looking visualizations like this one here. Okay. Now, one of the really great features, and this is most of our Bentley customers, the early stage customers, are taking great advantage of this, is that the integration between Omniverse and our Synchro construction animation capability. So what this allows you to do, so we're looking at the iTwin here, but this is one, it contains a schedule animation. So this is actually the Golden State Warrior Stadium that was built a few years ago. So let me go back to here. Hold on a second. I just want to make sure that everyone understands this. So what you're seeing here is that's the actual iTwin, and now you're going to see it inside of Omniverse. So we can take that same iModel with the construction sequence and bring it directly in Omniverse. Here's another example. This is the ITER fusion reactor project down in the south of France. The same thing. So we've taken the Synchro integration animation and then simulated it directly inside of Omniverse to give it a very nice set of materials and a very polished look.
It's wild.
It's huge.
So cool.
Yeah, cool, huh? Yeah. So here's some, I'm going to talk about some coming attractions here. This is our traffic authoring tool. So this is one of the really outstanding features in our legacy LumenRT products. So what you can do here is basically interactively create traffic. So you simply draw, the lanes of the traffic, or pick the lanes of the traffic if you've got vectors there, give it the parameters, and then it will create the traffic for you. Here's the output of the animation for this. There's another one here. So we'll be introducing this tool in our June update, which will also be using the new Kit 104 platform from Omniverse. So stay tuned for that one.
Nice.
I'm also, it looks really great. It's going to be a really fantastic feature. Another cool feature is we're working with our partners, Real Illusion, to bring in characters in, and you'll see some announcements on this in June that will talk not only about the ability to author, pedestrian animations inside of iClone and populate your scenes with characters, but we'll also be using our Legion pedestrian simulation tool to do very, very large scale pedestrian simulations and analysis. And we'll be talking, as I said, more about that in our June release.
Wow.
Yeah, really cool.
Yeah.
And then, of course, this leads right into our friends over at Cesium and the geospatial model. So this is, we had a chance to take some of the early phase products from Cesium and be able to integrate that. And this is a huge project from our friends at Hatch. It's a big mining project, and you can see that, we've taken the model, and then we're now streaming in all the geospatial data, directly from Cesium, and the Cesium folks, we'll take it from here and show you how to do that. So with that, I guess I'd like to end my presentation and then, hand it off to the Cesium folks who are going to walk through and show you how great it is to bring geospatial data into Omniverse.
That's awesome. Very fascinating.
Great, thanks. Okay, so
Okay.
we'll stop there.
Who would like to take the reins and follow that awesome presentation up? Good luck.
Ryan,
I will share my screen, and I think Ryan is going to go through our slides for everyone.
That's right. Yep. So I'm glad that I'm going after Dave because he's basically set the stage, and it's going to make my job really easy. Look, as you saw with all of those use cases, almost every single one happens in the real world, right? And they need and can benefit from having highly detailed, accurate geospatial data as context for a ton of different use cases. So, why have we invested in and made Cesium for Omniverse? It's to provide that capability. Those digital twins need that geospatial data, and as we've seen in our previous integrations with platforms like Unity and Unreal, being able to easily make it easy and make it fast to stream in this geospatial data is a key win. You don't have to wrangle gigabytes of models, try and get them running in your interactive app when you can just stream them from the cloud. So Adam, if you want to click through to the next one. So what is it exactly? So Cesium for Omniverse is an extension, and we've designed it so that it can work with any Omniverse app. It's not just a connector, but it is an extension which will run in the background with your Omniverse app. And it provides a couple of key things. Firstly, it provides an accurate WGS84 virtual globe, which uses our Cesium world terrain datasets, Bing imagery, Cesium OSN buildings as kind of like a base layer. But it also supports streaming in the 3D tiles open standard. And what that means is highly detailed photogrammetry data, terrain data, imagery, point cloud data in the future, any sort of big geospatial data in the 3D tiles format can be streamed into Omniverse with this extension. And you'll find that a lot of packages out there, drone survey, aerial imagery capture survey, generate 3D tile data sets for their survey data. And then the other piece is Cesium Ion integration. So Cesium Ion is our cloud-based platform, which is where you can store and generate your 3D tile data sets, or use a number of existing curated data sets that we've already seeded into Cesium Ion. So what that means, and as Adam will show very shortly, is with a handful of clicks, you can basically stream the Earth into Omniverse and begin doing whatever it is you need to do anywhere on the planet with a handful of clicks. It's super cool and easy. Jump to the next one, Adam, and then I'll hand it off to you. Cool. So typical use cases, and again, Dave's gone through a handful of these, but a couple of the key ones are to surround your design with real-world context, so you can make accurate and informed decisions, perform activities like sightline or shadow analysis, produce your outstanding visualizations, create interactive models or pre-rendered output to help with stakeholder engagement, show the community how the project is going to impact them, not just view the design in isolation. It basically helps with every single decision-making point from your early stage concept designs all the way through to operations and maintenance. The other thing that Cesium for Omniverse helps enable is visualizing drone or aerial 3D survey data. As I mentioned before, Bentley Context Capture is a fantastic product for generating those sorts of highly detailed 3D meshes, which we'll see shortly. That you might capture weekly or daily on a construction site. So being able to bring that straight into Omniverse again with minimal data manipulation or handling, and doing that across the cloud by streaming it rather than having to move around big data sets is a key use case here. And as I mentioned before, you can get started with the freely available context data from Cesium Ion to start building worlds really quickly, and may help with that challenge that was mentioned at the start of the live stream. So that's kind of it from me. I think let's just jump into the demo, because demos are really cool. I'll let you take over, Adam.
Yeah, sure. Thank you, Ryan. So let me go ahead and bring up Omniverse. So I've already got Omniverse running here. And we have our Cesium for Omniverse extension loaded, and just for the interest of time today, I've already signed into Cesium Ion because I will be using Cesium Ion assets today within this demo. So,
Adam,
So your screen is showing the paused slide deck. So
yeah, I think you may have shared window and not your.
yeah.
Yep, I'm sorry about that.
No worries.
Thank you for catching that.
Is it coming through now? Let me see.
Yes.
Yeah.
There we go.
Yeah, my apologies. I clicked the wrong thing for share. So, okay. So I've got Cesium for Omniverse opened up within a Omniverse kit application here. And I'm already logged into Cesium Ion just for the interest of time today. And so what I'm going to first do is I'm going to go ahead and click the Quick Add asset for Cesium World Terrain and Bing Maps aerial imagery. I'm going to select a token that I created earlier, and I'm going to go ahead and let that load in. And so real quick, you'll see that it will load up the Cesium World Terrain in a location near Denver, Colorado. And, you know, the first thing that I kind of notice is I'd like to add a little bit of better lighting to this. So what I'm going to do is I'm going to delete the default light that I have here. And I'm going to go ahead and create a dome light and then bring in a HDR map that I have. And already you can start to see the real power of the Omniverse system with all of the really, really nice lighting. I can bring in OpenStreetMap buildings with the click of a button under the Quick Add assets, and they pop in. You can see downtown Denver in the distance. And yeah, so what I'm going to go on from here is I'm actually going to bring in a design model that we have pre-prepared. It is properly located geospatially at the correct elevation, at the correct longitude and latitude. So what I'm going to do is I'm going to actually go over to the stage, and I'm going to choose our Cesium prim here, and I'm going to set the georeference origin point. So I'm going to type this in, and so these coordinates are the exact coordinates of the design model that I'm going to bring in, and this is located in Australia. So we load in, and then I'm going to set the georeference origin point to sea level. So the terrain itself is actually at the right height for this model. So I'm gonna zoom out a little bit and then let that kind of load in the tiles. And it should load in here in a moment. But while that's doing that, I'm gonna go ahead and pull in the design model that I have. So to do that, I'm going to go to File, Add Reference, then I'm going to choose my design model and choose Add Reference. And right away, you can see that it loads in, it's at the correct location, and now that the terrain has caught up and fully loaded in, you can actually see that it is actually one-to-one with the terrain. So, you know, this gives you, you know, all the kind of visual ability that you need to see. How is this going to impact, you know, areas? How is it going to change how things are shaded? You can see there's some shade here, but if we actually switch over to the interactive shade, it kind of makes it a little bit more apparent, the path tracing mode, where kind of the shadow of this building is going to sit, and you know where the shade is going to lie and how it's going to actually affect the environment around it. So just with a couple clicks of a button, you can pull in a highly detailed model. And, you can also do a little bit of editing in this model that is non-destructive. So say that we wanted to remove this gate. I can go here, and maybe it will actually let me choose it properly.
You might have to switch out of model mode, maybe.
Yeah, I'm not sure.
Yeah, it's because you're in group mode on the upper left icon above
Yeah.
your select.
Yeah, go to the upper left icon, click,
The other side.
select by item, yeah.
Yeah, that one.
That cube.
Yep.
Yeah.
Yep.
Nope.
Yeah.
Click the cube.
No, I clicked the wrong button. Yeah. Thank you.
There you go.
Yeah. And so, okay. Thank you guys. So now I've highlighted our gate here. I've deleted it. I deleted too much. And actually I didn't delete quite enough here because there was still a little some posts. So, since it's non-destructive, I can just go find the groups in particular. If I look at here, this is clearly the group with the fence gate, so I can just go here, delete these deltas, and there we go. We've got the fence with no gate. So, you can do all sorts of things. We can then save this USD. We can share it with our colleagues. We can do renders with it. Anything that you can, do in Omniverse, you can basically do at this point. So the other thing that I'm going to show today is I'm going to go over to a different asset. And so I'm going to load this in. And so this is a factory using some drone data that was provided to us by Bentley. And this is a very, very, very heavily detailed asset. This entire plant, the tile set for this plant, which is, again, properly geolocated and aligned within Cesium World Terrain, which you can see in the background. This entire plant is a 5 gigabyte file. Well, it's a 5 gigabyte 3D tile set file. And so the advantage of this, though, is that there is some extreme detail here. And while I'm zoomed out, you can see that the detail is not as heavy, but it's good enough for the range that I'm at. But if I start to zoom in, the power of 3D tiles and bringing that into Omniverse really starts to show itself. So as you can see, as I've come closer, higher and higher detail has come in. And at the moment, we are kind of at the highest level of detail for this particular drone. However, if you have even higher levels of detail data from your drones that you're using, or from satellites or whatever, you can use Cesium Ion, and you can use Cesium with Cesium for Omniverse to actually render your 3D tiles in all of the detail that you need. So we're excited to actually see what people are going to come up with for this. We just launched this about a month ago, and we just are releasing 0.6.0. I believe we released that today. And we're excited to see what the community comes up with.
That's really awesome. The performance of this is just incredible. This is really a breakthrough. So, we're really excited about, working with you folks at Cesium and the NVIDIA guys to really see what our customers can do with this, because it really is a breakthrough. Tremendous stuff.
It's wild.
Yeah, the amount of detail that you can get, even with flipping it over to the path tracing mode, and just starting to get more realistic shadows and stuff than you've been able to get before with this kind of detail is just it's incredible, and it constantly amazes us. And I know Sean and I we've been in the industry as 3D graphics engineers for quite a long while, and this just constantly amazes us. So, yeah.
just zoom out a bit and kind of show the context of how big this world is? I mean, you can basically keep zooming until you get to the globe if you really want to. But that's one of the cool things.
Oh, that's
you can sometimes
insane.
you can sometimes just end up exploring the world. You lose track of time. You just go to new places and go, oh, what's here? What's there?
Oh, wow.
Right. Yeah, I mean, essentially the entire globe is brought into this right now.
So what kind of computer specs do you need to run this? What are you using, Adam? What do you have?
So I will admit I'm running an A6000 in this computer, but I deal with some very large data sets just in the day-to-day with what we're doing with Cesium for Omniverse. Realistically, if you have an RTX-enabled card and your data set is, optimized correctly, and you set, in this case, I have the screen space air for this data set really, really low, so I can see more detail further out than I could otherwise. But if you've got a 2070, you can probably do this just fine. I will admit that this is actually a laptop, and I have an eGPU that has that A6000 in it. And there are times when I'm working without the eGPU, and all it has is a 3050 Ti in it. And it's there are hiccups and stuff, but overall it works overly fine. So if you can deal with a hiccup here and there, it can load pretty much, I would say, 90% of the data sets that I need, and that's only got 40 gigs of VRAM.
Yeah, that's pretty good.
I'm sorry, 4 gigs of VRAM, not 40. So yeah.
Yeah. So just to jump on that point a little bit, recommending any RTX capable graphics card with at least 16 gigabytes of video RAM. So that's like an RTX 5000 or better. An A6000. I'm very jealous you have one. I'd love to get one of those. But seriously, if folks want to start doing this thing, you need to, outfit your machines accordingly. I mean, I'm not being a shill for NVIDIA here, but if you want to do these breakthrough next generation things, you get the biggest, baddest graphics, card you can get your hands on. And by the way, as much video RAM as you can do, because if you want to put big projects on that, you need big amounts of memory, because all this stuff is being done in real time. There's no more offline rendering to a render farm. We're doing this in real time. Get a big graphics card. And I mean, the price of these things have come way, way down, right? I mean, before you couldn't even get one. I remember it was a year and a half ago, you couldn't even get a high-end RTX card. Now they're all over the place now, and they're just a few $1,000s for, a really high-end card. So
we're also seeing a lot of people leverage cloud instances. You can install Omniverse on AWS, and
that's
we have
right.
a tutorial for Azure coming up. So I think that's going to be a game changer for anyone who's looking to buy, their local setup. And it makes a lot of sense that Adam would have a really high-powered card as he's working on this tech. But most people would not really need to have a scene of that kind of caliber, which brings me to my next question: is what are you guys seeing so far in terms of you covered some of this, but like the industries that you think are going to be benefiting most in the near term? Can you tell us a bit about that and where you see things headed for the digital twins and using this tech?
So from the Bentley side, it's really going to cover the entire gamut from heavy civil users of folks that are building the large road projects, transit corridors, bridges, tunnels. Those have been the early adopters, but we now have folks that are in doing water projects. We showed at GTC the big Jacobs TWRP project in Singapore, the largest reclaimed water project in the world. And they're using Omniverse on it. The utility folks are doing all the new energy stuff. Are going to be a big adopters, and of course, one of our major customers, Hatch, is using Omniverse on all their big mining projects. So, I mean, anything where you've got big, infrastructure, big data that needs, big power like Omniverse to show it, is a great candidate for using this technology.
Adam showing the globe, and what have been the advantages of being able to collaborate? Someone had asked in the chat earlier if you guys are leveraging the collaboration features. Is that something? It seems like that a project this size would really require more than one person working together. Is that true, or?
So there's two types of collaboration. There's sort of ad hoc, what we call synchronous collaboration, which is what Omniverse does with their technology, LiveSync. And then there's what we call governed collaboration. So in the infrastructure world, yes, people work together, but when you make changes to things, there's a whole host of sign-offs and check-offs that need to occur to do that. So we have what's called governed synchronization. And by the way, Omniverse can work in both modes. So, you can use Nucleus to do the LiveSync stuff, or, connect into our digital twin technology, the governed synchronous stuff. So, in other words, on the governed side, bring the changes in as the iTwin is updated. It goes through the governed process of review and approvals. They push those changes forward, and then you can synchronize that in the Omniverse. Or if you want to work in this sort of sandbox environment with Nucleus and LiveSync, you can do that as well. So what's cool about Omniverse is that it supports both styles of engagement. So, and in our world, we need both.
Very, very cool. Great questions from the chat. Great conversation happening there. Great community. Super excited about this stuff. We have a question from Zia. Do we have a way of dealing with trees and large-scale forests? How do you guys deal with terrain like that? I guess it comes in from the drone also, or is that coming from other sources like Cesium's?
So in our world, so we've got a couple of solutions that we offer for that. So our sister company, Eon Software, makes a product called Plant Factory that's also part of Omniverse, where you can take and generate all kinds of forests of vegetation and trees and things blowing in the wind. For most of the infrastructure projects, because of the fidelity that Cesium offers on this stuff with these drones, I mean, you can take drone data in at 3 millimeters today. I mean, okay, yes, the trees are not blowing in the wind, with that kind of stuff. But if you want really high fidelity, vegetation forest, you can do it with the Cesium technology easily today. Where just a few years ago it was next to impossible. But with the Cesium open tile format, we can now do that routinely. So it depends what you want. If you want to get real life up to date stuff on the context, use Cesium. If you want to do more sort of futuristic animation, avatar type stuff, you can use the Eon Software plant library. Which, by the way, that plant library was used in all the Avatar movies. So if you saw the new Avatar, all the water plants and everything was done using Eon Software.
That's awesome. We've been talking about having those folks on the live stream, so we need to.
Yeah. I should get a hold of Matt and those guys over there. They have some really cool stuff.
Very cool. Let me see. I'm trying to think. Are there any other questions from the crowd or from the panelists here with us? We have a couple minutes left to go. Otherwise, we can always hop over to Discord server onto the community voice room and open it up to the community to kind of unmute themselves and talk to us live.
Yeah, I think that's a great idea. I just wanted to thank Dave again and the Cesium team for being here. I think you guys just demonstrated really well why these full fidelity models are beyond Hollywood, like you said, Dave, and it's super important trying to build these accurate digital twins, which is going to be huge for the industry. So thank you guys for building these solutions.
And thanks to NVIDIA and the Cesium team for working with us on this. Much appreciated.
Yeah, hopefully we'll have you both back super soon.
Yep.
Absolutely.
Cool.
Yes.
Well, thank you, everybody. To echo Krista, I really appreciate everyone's time and thoughtfulness into the presentation we started today. Really great workflow. We love seeing when we can walk everybody through exactly how to execute something, and you guys have done that in spades. Great questions from the community. Can't thank you all enough for watching and for engaging with us there. So let's do this. We're going to go over to the Omniverse Discord server, and that's discord.gg/NVIDIA Omniverse. We're going to hop over to Community Room 1. And you are free to unmute yourself if you join us there, or turn on your webcam if you want, and you could chat with us for a few minutes there before we let everybody go. Thank you everybody for joining us today. Super exciting content. We'll update the table of contents for this and the description, and post any links in the video description. So if you missed any part of it, it'll be on YouTube. Any last words from anybody?
Thank you.
Robert, you have been deceptively quiet. I know you're steaming something in your brain, but what were your thoughts on all this?
I know I have been silent. So, yeah, so it's something I play with a lot, and I think one of the cool things, just to kind of get some words in there, is that, what you saw from like Bentley was these amazingly highly detailed, complex models, but then the minute he dropped the terrain in, it like took it to a whole nother level, right? Like, so models in context are incredibly important, right? Not just for visuals and things like that, but it is for shadow studies and light access, and there's so many things you need to do with models in context. So that was one thing. And then the other thing that I think that showcased there is, like, I don't know if people realize just the sheer amount of geometry when you individually that was on the screen, and then combined, it's just mind-boggling, right? Like, they would, Dave had one thing where he's like, oh, and I'm showing you like the ITER model, right? Like, there's literally like, one of the most complex, it's gigabytes of data, and like he's just zooming around like it was nothing, right? Like it was a video game. But like you can zoom in and like you can see like the bolts, and the little nuts and all the pieces in there. And so what I think is amazing to just kind of understand is like at the scale that they were presenting at, it's really mind-blowing, because it was near impossible to kind of be able to move through worlds like that at the speed we're moving through now. So
Absolutely.
It's a totally brilliant points, Robert. I'm so glad I just called on you.
I know. I was like, this one I was like a little quiet. I was like in the background. Everybody else talking.
No, it's great. It's great. That was the perfect way to close the stream, actually. So thank you, everybody. And Krista, thank you so much for you and the AECO team for putting this together. We look forward to the next part in your amazing AECO series. We have a playlist on YouTube if you guys want to watch the rest. We're going to hop over to Discord now. So come on over to Discord. Maddie has got his live stream tomorrow if you want some help with Python stuff. I believe that's at 10 a.m. Eastern on the NVIDIA and Twitch and YouTube channels. Otherwise, check out the calendar for upcoming live streams, including next week on Wednesday, same time as this one. We're going to have Adobe on. We're going to do a deep dive into how you can use Substance and Omniverse together for some really, really cool way. Particularly, it's about editing defects and stuff. So pretty neat concept everyone's talking about lately. Okay, thank you, everybody. Really, really fun stream. We're going to hop over to the voice channel now, and hopefully we'll see some of you there with us.
Great.
Yep. Awesome. Bye, everyone.
Take care.